this is the one, okay. Can you see it now?
Yes.
Okay. So these are just a few slides, and I think I added one compared to the one that I posted on the Slack channel. So I'll post this updated one, but it's not too much of a change. Essentially, as I said, just a quick walkthrough of the data block API. So in the future as well, you have the slides to go to for summary of some of the things that we'll discuss. So the key concepts that he goes through in the tutorial notebook, which we'll get to in a minute, are covered in these slides. The point being that with FastAI 2, he's provided kind of a multi-level API for covering or for gathering the data. What's meant by the multi-level API, because we'll talk about high-level, mid-level, and low-level APIs. And so just to introduce the high-level APIs, and you can go back, and when we get to the notebooks part, I'll kind of share the introductory very first notebook of the FastAI version 4 lectures, in which he very quickly creates a data loader using this image loaders from name function, provides the path of the data, provides this get image files from the path, the validation percentages, seed for randomization, the label function and item. And then immediately after that, he just goes into creating a learner and then learning. That's for classification. Similarly, for segmentation, the high-level API just says segmentation data loaders from label function, and then boom, 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 it just provides the options, and off you go on segmentation. Similarly, for text classification and for tabular data. These are just illustrative, and in fact, if you go through the introductory notebooks, you'll find all of these used there. And then you see that in FastAI 2, there's also the low and especially the mid-level API, which are used for building the data structure that you need for the learner. The low-level API is something that offers you full flexibility, as we have seen with transforms and other code. He offers the ability to modify just about anything and every aspect of the data building pipeline. So you can create and use pipelines, which means essentially build your own transforms, compose them into pipelines, and so on and so forth. And then from those, you can build data sets. Remember that those are just essentially collection structures which have a length and which can get you an item through an index or through an iterator, and data loaders, which are fundamentally generators or iterators, which gives you a batch of data at a time. And when you don't specify the batch, it gives you all of it, as we saw in the data loaders lecture. The key that we'll cover in this lecture in much more detail is the mid-level API, which he has provided with FastAI 2. And that's the concept of a data block. And why is this useful and unique with respect to, it wasn't there in FastAI version 1, but it's available in FastAI version 2, because it gives high flexibility, but so it provides almost as good flexibility as the low-level API, but we don't need to do as much work as we need to do with the low-level API. Certain things are already, we can use certain blocks and certain constructs that are already provided for us. And he'll go through several examples in the lecture and in the notebook. So this is just, again, summary, what you need to provide for the data block API, and we'll repeat this for various examples. We'll need to provide the type of blocks, and what it means will become obvious as we go through the rest of the lecture. Things like, is it an image block? Is it a category block? Is it a multi-category block? Is it a bounding box block? And so on and so forth. So the type of blocks. Getters, we have seen that in the lecture that QB took us through. I think it was the second lecture, to get the X's, and there could be multiple Y's depending on what kind of data you're processing. Labelers, to label the Y's or the targets. Splitters, in order to generate the training and validation sets within the data sets and data loaders. So you'll get subsets of the data set or subsets of data loaders, one being the training data loader or training data set, and the other being validation. And there could be multiple as well there. Item transforms are applied after you get the items through the getters, and batch transforms are applied after identical sized batches in case of images, for example, or identical sized data in case of text are created. So the data block API, the block type depends on the problem that's being solved. As I mentioned, whether you're doing image classification, segmentation, are you handling tabular data, are you handling text data and building a language model, or are you handling text data and building a classification model, and so on and so forth. And also, where does your data come from? Does it come from folders? Does it come from data frame? And similar options we'll see in more detail. So these are the various types of blocks that are available. I just wanted to list them in a single place, handy to go back to refer to if you're building a data block yourself. Image, category, multi-category, mask when you do segmentation, point blank, point block when you do a particular position on an image, if you want to kind of identify the center of the face, as we'll see in an example. The bounding box block, the bounding box label block, text blocks, and then tabular data. Tabular data is handled slightly differently, and we have subsequent lectures coming up that will get into the details of that much more in depth. Next piece that we'll need to provide to a data block are getters. And these are, as you can see, and as we went through the code, previous lectures, get files, get image files, get text files. And then obviously it's defined convenience function. If you go back and look at that lecture, file getters, image getters, item getters, and get X and get Y, you can directly supply. I threw them in with getters because ultimately they're also functions that help you to get either the data for the X value or the data for the target or the Y value. And if there are more than one Y or target labels, then you use n input equals 1 or 2 or whatever the number you have. And the data block API is smart enough to know that if you provide n input is 1, anything beyond 1 that you provide is considered a label. We'll look at that example in detail in the notebook.
Sorry, please. The n inputs, it's X I handles, not the Y's. The last bullet.
Yes.
And it's handled if there are more than one X, not Y.
Sorry, I couldn't quite hear you.
Like the last, can you hear me? Yeah, use n imp if there are more than one X and not Y.
If there are more than one X, you're saying?
Yes.
Yeah, that's correct. Sorry, my mistake. I'll probably edit that. I thought he maybe said X and I just copied that. So if there's more than one input,
Yes.
then you can use X, but I thought it also is the case that if you had, for example, multiple labels, but then you would handle it through multi-category. So you're right. It's probably more than one X. Yeah.
Yes.
Good catch. Thanks. Then moving along, labelers. So these are the ways you label the targets. Parent label, regex labels. We look at column reader in case of the tabular data. Then we go to splitters, and you can see that there's a whole host of them. The idea being you can use any one of these splitters to create the split between your training and validation set. So you can do that randomly. You can use it. You can use the sklearn train test splitter. You can use the index splitter using the indices from your data set. You can use grandparent splitter, as I think we do in MNIST. You can use a function to create a splitter. You can use a mass splitter. You can use a file, column, random subset. And then after processing the item, you can have specify item transforms in a list, which would be a pipeline of transforms that get applied to the item. We'll see an example of this. And you do batch transforms and specify the set of transforms you apply to the batch. For example, augmentation transforms. Item transforms could be things like resizing the image, making it of a particular type, things like that. Again, all of this, I just wanted everything listed in a single place and to give you the concept of the kind of data that you would need to provide to a data block before we dive into the notebook itself, where we'll see the specific examples. Okay, so I'll stop sharing and switch to the notebook in a minute here.
Or someone else, on the item transforms, are there any other examples other than size?
Sorry, could you repeat that?
For the item transforms, are there some other types other than just size?
The one I've seen is resize. There could be others. You would obviously resize the image. There could be potentially, I guess, cropping, which is kind of like resizing as well. So think of it as things you would do after you get an item and before you collate them as a batch. Okay, can you folks see my screen now?
Yep. Yeah.
Okay. So I've already run kind of the initialization part of it, if you will. So we'll start from here, downloaded the data so that we need not wait. But bottom line is this is the tutorial, and I've added a few notes, not too many changes, but in the tutorial, it kind of takes us to the data block API on a variety of tasks and also how to debug them. The data block takes its name from how it's designed. It can be used, as I explained, to build either the data loaders, or you can build data set module of the data block, and we'll see both of that in a minute. So it'll get just, the rest of the notebook is just example after example of how you build the various data blocks. Import the data. Let's say we get the file names for which you provide the path. And in this case, initially we'll begin by building an empty data block. So we just create the data block class by calling it. And then it's just a blueprint, as he says, of how to assemble. You have to pass the data block, the source, that's the path to your data typically. And then you can choose to build either a data set or data loaders by using the data sets or the data loaders methods of the data block. Now, typically you would do the data loaders after you've built a batch and provide to the data loaders the batch size as well. And because we haven't done any of that, we'll just start with the data set. And so what we do is just say data sets is the data sets method of data block and pass in the file names that I've just downloaded up here. And then look at the 0th index of the train subset of the data set. So that's what we do with this. And you see that, for that particular, obviously there's a pets images that I downloaded here, URL pets. Therefore, you see that it's a path to a single image, but you also see that there are two of those, right, in a tuple. And that's because the data block API assumes that we have a input and a target, an X and a Y by default. So that's why you see the file name repeated twice. So the first thing we can do is pass the data sets method within data block, a get items method. And as we saw in the data loaders lecture, a couple of lectures back, I think, you could kind of pass in methods to the classes in FastAI, certain specific classes, and data block is one of them. So you can actually pass in get items equals get image files. So what this is doing is replacing the get items method within data block with the get image files function. And that becomes a method. So you create a data block version which has get image files, or which runs the function get image files when you say get items, or when it executes the get items method. So then when you pass in the path where the images are, then you can automatically find that it goes and gets the image files. In this case, it's the Russian blue.
A question
And
on that.
yes.
When you're doing get items, aren't you saying that that will be both for the source and the target?
Yes.
For the
X and
input
Y
and the
for
target?
right now. Yes. Right now it's doing it, and we'll see later on how to change that to do something different for the X and Y.
Okay, thank you.
And then
also, when we say data sets of path images, it automatically knows we're referring to the get items function.
it goes and grabs the items from the path. Yes.
Okay, because, I mean, we're not saying something like data set of get image files of.
No, we're not. It's just building the data sets method of the data block, calling it dsets, passing in the path. Basically, this is a data block itself. dblock.datasets is actually just it is a data set, and it uses the data block defined here. Therefore, it's a data block with its get items method replaced with get image file. Since he's building it piece by piece, it seems a little more complicated. By the time you get to the data block, it'll become a lot simpler to understand what you need to pass. So since he's building it from the bottom up, it's a little bit more confusing or incremental, but once we get to what do we need to supply to a data block as a whole, it's actually easier to comprehend. So in this case, as I said, it's a tuple, so it gets the same image twice because it thinks it needs to get an X and a Y. And in this case, it doesn't know any better than to run the same get image file for both. Our inputs are ready to be processed, but obviously, just what I said, the target is not, because the target is still an image, which is not what we want. Since in this particular instance, we are trying to use the data block that we are building for a cat versus dog classifier. So what we need to do is to make the target from the image become a cat or a dog, right? So if you go back and look at the introductory cat versus dog problem, you'll see that if the file name begins with an uppercase, it's a cat, otherwise it's a dog. That's the way he has it set up. So he defines the label function and passes in the same file name. It's this guy, and I believe this is a cat, if I'm not mistaken. But he passes in the label function and passes in the file name, and it basically returns a cat if the name of that particular file name is in uppercase, otherwise returns dog. And these are strings. So you define the label function, and then now you see the answer to your earlier question. You define the data block and pass it get items or get image files, and get Y as a label function. So it knows to get the items using this function and then pass to the get y, or the get y acts on the second of these, that the second index of the tuple that's acquired through get image files. So it runs the label function on that, which says, is it a cat or a dog? And then when you run or create the data sets, I was wrong. Well, in this case, it's running it on the Pomeranian, so it's a dog. So you get the label, which is a string dog, because you have run the label function, which is passed in as the get y function, on what you get as the second of your inputs to the tuple. And as I keep repeating, it will become a lot simpler as we get to building the entire data block in one go. So now
I'm sorry, quick question, because I got a little confused. Why don't we do get X for get image files? Is it just generic to do get items and then just overload the one?
Yeah, good question. I don't recall off the top of my head. I think the get items gets a tuple. The get X will apply only to one instance, so probably you want the tuple, and then get Y to apply it for the label. But we'll see an example of where he applies get X and get Y in as we go down. So if that's not a complete or a incorrect answer, hold the thought and re-ask the question as we get further down. I may not have given a complete answer. So hold that thought. My initial reaction is to say that get items gets you tuple, which then you can, you don't need to do anything in this case for get X. So we leave it untouched and you only apply get Y. But if you just did get X, get Y, then you would only get the X, which is only the input, and you'll need to do something separate. Your get Y will not work or until you have a tuple, because get Y would only apply to the second part of the tuple. So you'll probably need a get items to get the tuple, is my thought, but I haven't thought through it deeply. And we'll check whether that's true or not as we go through the notebook. So now that the inputs and targets are ready, we can specify the types of, I think this is to Anand's earlier question, we can specify the types to, no, actually he has more in the context of get items, but in this case, the things we specify are image blocks and category block, because our X input is an image, our Y is a category such as dog or cat or whatever. And so you say blocks, image block, and category block. So you tell the data block API that our inputs are images and our targets are categories. And the types are represented by blocks in the data block API. So that's why you say use the word image and then block, capital, category, and then block. So the thing I commented here is the fact that, again, what we are doing is defining the things that you pass into a data block, and then call the data sets method of the data block and create a data set by just passing in the source of your files or your location of all of your files. So you create a data block, say data block, blocks, image, category, get items is get image files, get Y is label function. And then you create data sets, this data block data sets, pass in the source, and then you go look at what's the 0th index of train, and you should. Now here, what is interesting, you'll see, is the fact that it's actually created an image for using the image block, but also because of the use of category block, it's converted this dog or cat string. It would vary on depending on the image that you're looking at. In our case, it happens to be dog. And the interesting thing is it is converted to tensor category 1. It doesn't, in the data, because we want it to be ready to pass into the learner, we want this to be actually a tensor and not a string. So it's converted by passing in a category block to a data block here, this particular label has been converted to a tensor. It's of type tensor category 1. Okay, and that's kind of happens because we have passed in a category block. And this is the beauty of data block, because you would need to build all this in yourself if you are working right off of PyTorch. For example, the conversion of that value, which is a label, to category, to a tensor. So you can see that it automatically added the transform necessary to open the image, and also it changed the name cat or dog to an index and to a special tensor type, right? And it has internally built a vocab. So if you look at the datasets.vocab for what is the vocabulary of the datasets that it has built based on getting all the items from the image path, you look at it and it says cat and dog. So this tensor category 1 is dog, tensor category 0 is cat. And that's happened because the data block functionality, when you provided these options, builds internally a vocab. Now is where it gets interesting. You can mix and match any block for input and targets. And you can also have more than 2 blocks if you have multiple. And you can pass in the number of inputs to data block to tell the library how many inputs there are. So I think thanks for catching that mistake. It is X and the rest would be targets. And pass a list of functions to either to get X or to get Y to explain how to process each item after you've gotten it. So to be ready for its type. So we'll see the object detection where we'll use get X, get Y after we get items. So the next step obviously is to, so far we have only created the training data set. We also want a validation set. And for that we use a splitter. So everything before that remains the same. In this case, we have provided a splitter and said, do a random split. So that's all we do new in this cell, and build the data block again. And what you will see when you provide a random splitter is you'll see, and we have looked at this before, is a couple of subsets are created. So index 0 subset is the training set, and index 1 subset is the validation set. And in fact, you can build, I haven't tried it or played with it yet, but you can build more than 2 more. You can build multiple validation sets. So if you look at dsets.valid0, just like train 0, then you see another dog. Now, one of the things you see in this, as you notice, is the size of the images are all different. Actually, I didn't do 2 training or validation set, but well, this one is 480 by 330. That one is 353 by 500. While keeping in mind that this is a validation set, but it's just split it from the entire source. So obviously source is having images of different sizes. You can see that it's 500 by 333. So if you don't resize them, then you can't create a batch out of them, because remember that your batches all have to be, batched images all have to be of the same size. Otherwise the GPU wouldn't be able to process them.
On the random splitter, did you say that we can create more than one validation?
Sorry, you're breaking up, Anand.
Oh, sorry. I'm going to say the random splitter, you said you can do more than one validation set?
No, it's just one. It's just one. I just said you could, if you wanted. He talks about it. I haven't tried it, played with it to see how best to do it, but you can build more validation sets if you wanted to. In this case, it just splits it into 2. So that's why the number of subsets is just 2. A 0 is training set and 1 is validation set.
Just one.
And then
comment.
the last, sorry.
Just one comment over there, that to keep in mind that random splitter is actually an instantiation of an object that you're passing in, whereas getY is actually like the function there.
A function,
so,
yeah.
So just to keep in mind,
this
that's
is
a common error.
To a random splitter, yeah.
And to answer Anand's question, random splitter is just passing you back a list of indices. So if you pass in a list of a varying number of indices, it will just create multiple validation sets.
Is it possible to directly give a place just a list of
Yeah, I think Srinivas has an example where he was talking about the sklearn splitter that you can use. So like you can do cross-val there.
Yeah, actually, I've also worked with a notebook where you can use the sklearn stratified splitter
Right.
as well.
that was what I was.
Did you have a question, Anant, or?
Yeah, no,
Sorry? Did you have a question?
no.
Oh, okay. So, and then just as I was saying, because these images are of different size, in order to make them all of the same size before we apply the batch transforms to the item transforms, and the same thing as what Raquel said applies. You pass in a resize function with the value that you want to resize it to, which is 224. So that means all images coming in to you after you've gotten the items, you've labeled them, you've split them. The item transforms applies the resize transform, which means that all images, both in the training and in the validation set, will get resized to 224 by 224. Now, once you've done all this, you can then create, now that we have everything of the same size, you can move from creating or using data loaders, which require, in a sense, the data loaders, when you use show batch especially, they need to be of the same size because we're using a batch function with them, which means all these images that are displayed will need to be of the same dimensions. And so we build the data block and use the data loaders method of the data block. Again, just like with dataset, you pass it the source of your images, call it DLS to indicate it's a data loaders, and you can execute the show batch function of the data loaders. And obviously we saw that in the data loaders discussion, it'll give you 9 images. Now, what is fascinating, as you can see, and this is the beauty of FastAI, among the many things, but just wanted to call your attention to it as I have in the notes. Because of the fact that you have built a transform which has an encode and a decode, the show batch is able to understand and retranslate from a tensor category 1 or 0, which is a tensor, back using the vocab to the label, whether it's a dog or a cat, when you use the show batch function. Because the show batch, in turn, as I've mentioned previously, calls decode, and the decode converts the category back into what it used to be, which is it knows it comes from a vocab that uses a dog or a cat. That's how you get the labels back. So that's what makes FastAI so useful. Is, if you didn't have it, you would be stuck with saying, oh, I have a tensor. Now what do I do? When I go back to showing an image, how the hell do I know that the tensor category 1 should actually be a dog and the tensor category 0 should be a cat? You know that because of the inbuilt nature of transforms and decode within transforms, which remembers how it was encoded. That's why you get the labels.
Same thing with the image too, right? The normalization and the denormalization.
Yeah,
all
the
that is taken care of.
Yeah, you're right. Yeah, exactly. Now we get into kind of the specific examples of how we build the data block. And here's a really good way of thinking about it. This is why I also provided the slide, so you can kind of go back to it and refer to what are your options when you want to answer these questions. So how do you build a data block? Well, you go about answering a bunch of questions. What's the type of your target? Inputs and targets. Well, your input is of type image, your target is category. So we got that. Where's your data? Well, we'll give it, in this case, it's in subfolders, we'll give it the path name. Does something need to be applied to inputs? And this kind of begins to touch on QB's question earlier, which is that if you want to apply some get X to the image after you get it through the get images, then you would do it right here through something in get X, but we don't need it here, but we will need it elsewhere. So you use getX to do something to your input after you've gotten it through the get files function or the get image files function. Does something need to be applied? Yes. In this case, we need the label function to be applied to the target to get the target. How do you split? Random. That's why random splitter. Do we need to apply something on the formed items? Yes, because the images are all of different sizes. So we need to apply a resize. Do we need to do something on the formed batches? In this case, no. So this gives us, depending on the answers to this question and the list of choices which are there in the slides I provided, you can answer these and build this data block. Right.
What's the difference between item transforms, the use of item transforms here, and something, and why? I mean, why couldn't you use item transforms as your get Y? Or sorry, the resize function as your, sorry, let me start again. Why couldn't you use resize as your get X? Because isn't that something you have to do after you get the images?
You could potentially do that. I haven't tried it. You could play with it to say get X is resize
Yes.
24. But if you think about it, I think the reason is you may want to do more than just the resize. This is just one function he has used in a simple example, but item transforms are things that you want to do to the images after you've gotten them. The get X is typically used for other functions, as we'll see with further examples downstream. But so my best answer at this point is it's more of a natural fit because you will combine into a pipeline all of the transforms you want to do on items. But it's an interesting question of what would happen if you just said get X is resize 224. And it may be that the other thing I would say is, and I don't know this, I'll need to go through the transform code to figure out whether this is what I'm about to say is actually true or not. But I also don't know whether the transforms are, whether there is a speed aspect involved in getX and applying it versus applying it as a pipeline set of transforms when you provide it here. That's something I'll need to investigate further.
I see. So the idea is that maybe getX is kind of like not really necessary. It's kind of an additional feature, but you don't really ever need it because you can always fold into item transforms anything that you would do with getX. Or at least that's my supposition.
Hold the thought until we get through all of the examples. I'm not sure whether what you're saying will hold true. I'll have to think whether it holds true in all of the examples that we'll see further down the road. But it's an interesting thought. It's a good thought to play with to figure out what happens.
Yeah. Sorry, and just a last question on the item transforms. So the way that we're using Enrisa, just following on what Joseph said, means we're applying it to the input. So the item transform is not applied to the target. It's only applied to the inputs. Or is it one of these that is overload and it applies to both? In this case, then when we do the checking of the types, it only applies to the image block, not to the category block. That's why.
Excellent question. I think because it's a transform, it would mean that it would probably depend on the data type, and the data type of the label is more a string or a tensor category. So it probably will not apply, but it will apply to the images. So it's using the typing of the transforms is my guess as to why it applies to the X and not to the Y. It's based on, remember, resize becomes a transform, and transforms will only apply depending on the data type. And resize, if we look at it, will probably be applicable to tensor images and not to anything else. So only tensor images will get resized as they go through the item transforms resize. Are you following, or do you understand?
Yeah, that was good. Thank you.
Yeah, tensor images, tensor blocks, and tensor points. Those are the ones
Right.
which kind of get resized.
Which get transformed. Otherwise, the rest of it, like tensor category and stuff,
Right,
won't be
should
touched.
not be touched, yeah. And going back to, I think, Joseph's question, the get X here clearly basically is going to act on the file name.
Yes.
So once you do not get the file name, you cannot do a resize on that. You first need to apply how to get the file name from your get items. And then you will open the image. Only after you open the image can you do a resize on it.
Yes.
But then
that's
going
an
back,
excellent point. Yeah.
yeah, but going back to the power of this, I think to mention is this label func is something which is not really defined in FastAI, right? Like random splitter is something that is defined. Label func is showing you the power that you can write any function you want and squeeze that in over there, and the data block will be able to figure it out from a file name.
Yeah.
So you could do a getX, which would read the file and then do the resize, squeeze that all in one function, and then throw that there.
Yeah.
Yeah.
Did you get that, Joseph? I think that's
so to Anand's point, then why? I mean, to that point, why haven't we done getX? You're saying you need to have getX in order to get the file name in order to do the resize. So how come there's no getX here?
So getX and getY by default, if not supplied, like how Srinivas showed the example, get items does the job. So getX is equal to like get items, and getY is equal to get items by default. It's basically just the file names. So once you got the getY to be equal to the file name, we realized that that was not the tensor category that you wanted. So then when you have the file name there, if you apply label func on the file name, that will extract out the name of the dog or the cat. And in this case, we were doing something more specific, whether it is a cat or a dog. So it was just binary.
So yeah, Vikil's point is we get the name of the function already by doing get image or items, get items. And that's good enough for what we need to do with the image, because then the item transform opens this and resizes it and stuff. But the point is that for a label, this name is not enough. That's why you have to further process using the label function. And to highlight what Rakel said, he was pointing to a very powerful capability, which is, remember, this is a function we define. So this function could be anything, and you can pass it in and it'll use it as the function to replace getY. So the thing he was explaining in a sense is you could build a getX which takes this, opens and stuff, opens the image, resizes it, then you wouldn't need to do a get item. So, I mean, of course, that's getting fancy because you already have it built in, but you could do that. That's the beauty of FastAI.
Okay, so I guess the question is, and I'll wait for you to elucidate the answer because it's probably coming, but my question is, why is there a getX? I don't see a use.
And you'll see examples of where it's needed. Yes,
okay.
It will come up in the next examples as we go through. None of the capabilities he provides, and he is very sparse in, he's quite parsimonious in providing capabilities in FastAI, meaning he doesn't provide things which aren't useful in many scenarios. Let's see. Okay, this might require, so, he just says, let's start with image classification. And then as we go through and cover all the rest of the examples, we'll see more and more usage of multiple things. Let's see. So here so here you do a data block, and the type of block is image block, but the class, because it's MNIST and it's a black and white image, so you say class is PIL image black and white. And then again, obviously, we are just going with a label for, excuse me, a category for a label. So category block, get items is get image files. But look at the splitter now. The splitter is a grandparent splitter, because if you go back and look at the way the MNIST files are structured, you want, excuse me, to split based on 2 levels up from where you are. So that's why a grandparent, not just the parent, but the parent's parent. And you can go through the MNIST data structure and figure out for yourself why it's a grandparent splitter. And the get y, excuse me, is a parent label. Again, why parent label? Because you'll see that the file names are typically, the folder names are typically all either 3, 7, 5, or numbers. And those numbers are the category of the images which are within that folder. So that's why get y is parent label, whereas splitter is grandparent splitter. So he explains that here in this. One for images and then one for category. The subfolder for all image names is done through using this. The split train is using grandparent splitter, and we use parent label for the targets. And then I have listed in the slides all of the transforms, or at least I hope I captured them all. If you find anything that is in there, feel free to add, but I think I captured all of it when I looked through the code. So again, the data block itself is just a blueprint, and it doesn't check for errors. You have to kind of feed it the source of the data. So in this case, you build the data loaders because, again, just FYI, we are building the data loaders directly from MNIST because all MNIST images are the same size, unlike the pets example we saw earlier. That's why we can build a data loader. Otherwise, you'll need to go through items and resize and then build the batch and build a data loader. But we don't need that because all MNIST images are 28 by 28. And once we build the data loader, we can obviously do the same thing as show batch. And you see the labels and the images. And you build the data block by using data block and providing answers to these questions. Now, one of the things that is interesting and useful is you can do an MNIST summary or whatever the data block name is, dot summary, and it'll give you a lot of detail about the data block. So what is it? What is the vocabulary of the categorized transform that got applied? Where does the, what is the label of the, where does the label come from? And applying parent label gives 7. So if you see anything going weird or strange with application of the parent label function, you can see that. How do you build a single example? What are the data sets? There are 2 data sets of size this and this, because obviously you have already, if I'm not mistaken, provided
from your grandparent splitter.
Splitter, yeah, splitter. That's the thing I was looking for. So on and so forth. So that gives you an ability to really go up. See, and also to you, many of your questions, setting up after items or pipeline, it converts it to a tensor. Setting up before batch pipeline, it does nothing because we haven't specified anything. Setting up after batch, actually we haven't specified to tensor either, but it does it as a default. Then setting up after batch, it does an int to float tensor when it does the normalization in div mask. Building one batch, and we'll look at the data block code in detail in a further lecture coming up later, but this is, the summary function is very useful in debugging how the data block gets set up in case you have any issues as you go through them.
Could you remove the definition of the class where you state that it's going to be a black and white fill image just to see what kind of error you get or if it gets detected?
It should just treat it as an RGB image, right?
Sorry?
If you don't pass PIL image BW, shouldn't it just treat it as an RGB image?
That's my guess, but she's saying do this. Let me see.
So instead of representing it in grayscale, you'll kind of see the colors flip, I think. The background will become black and the 3 will become 5. I mean, will become white.
Likely this stuff that will happen. We want to execute, well, we want to execute without that, right? That's what Raquel said. So it doesn't really give an error, but
the difference will be in, I think, it just mentions PIL base.create, and internally
you'll
that
see a
uses,
different function if
I think
change this
I think create underneath uses, I think it does not show here, right? Because create on the underneath would use BW or RGB.
Yeah.
So I don't think you'll
Eventually
see
you
it
get
here.
to one or the other.
Yeah, correct. Yeah. Actually, the much cooler example, if you want to see how the error is, I think if you miss out a resize, it very explicitly says that your batches cannot be formed because your sizes are not the same.
Yeah, so that will be very useful to realize.
Yeah, exactly.
That,
so
hey,
data block summary is like a very, very helpful decoding thing.
And basically it's very flexible, but at the same time, it doesn't need the level of detail that you will need if you were to, which did not, this data block API, the mid-level API as he calls it, didn't exist in FastAI version 1. So you either had to do everything bottom up or you just were stuck with a very high level usage, which provided you all the capabilities, but took away a lot of the flexibility. So this mid-level gives you most of the flexibility with also the capability to reuse a bunch of stuff. So moving on, let's look at how it's applied for pets, which has a single label, but again, different. Same thing as before. Now they're not of the same size and 37 different breeds instead of just a cat or a dog. In MNest, as I said, everything is 28. Here they have different aspect ratios, blah, blah, blah. We want it, and we are going to add data augmentation here. So obviously we will do the data augmentation after we have built a batch, because we want to do data augmentation on the GPU when all the images are of the same size, and augmentation can be done faster that way. So again, questions, what do we have? Same thing as before, images, labels, where's the data in subfolders? What do we want to do with the split? Well, let's just stick with a random split here. How do we know the label? By looking at the parent folder. So in this case, label will be a parent folder function. Do we want to apply a function to a given sample? Yes. In this case, the item transform, therefore, will have the resize. And do we want to apply a function to a batch? Well, we want augmentation. So that's why we will augment the data. Ignore this, but you can go through it if you want. It's more the fact that, as always, I was interested in what the attribute getter function does, which he provides for attribute getter of name and then applies the regex label. It just gets the name attribute. It's another helper function that Jeremy uses. But more important, data block. Blocks are these two types. Get items are image files. Splitter is random. Get Y. In this case, we supply it a pipeline because ultimately get Y, get X and things are transforms. So you just say pipeline, and remember a pipeline is provided as a list, and this is a function which gets transformed to a pipeline. And then this is another function which gets this attribute getter is a function that gets made into a transform, and this regex labeler is again a function that gets converted to a transform. So it goes, the pipeline applies this transform to the second value of the tuple that you get from get image files, and then the regex labeler applies the label, or applies actually this, calls this function on it, which creates the label. Item transforms, resize, batch transforms, you apply the aug transforms and whatever is the default augmentation, right? So you do that. And now again, because you've applied the batch and all the images of the same size and stuff, you can use data loaders, pass it directly the untar command, and where this untar function would put the images in this particular path. And you can just go ahead and execute the show batch function with a maxx. So you can see again, it's built its own internal vocabulary of 37 classes. And that's the reason it gives the labels. And as Raquel said, it also has denorm when it moves forward to classify the images, which we haven't done here, but when you do the learner and apply the losses and stuff, it will use these labels actually as tensor values, and the images would all be normalized. When it shows them, it goes in reverse using decode and uses the vocab to build the labels and denormalizes the label images to actually show them in their original form, of course, of the same size, because we have applied resize. That's, I think, a lot of data processing going on in the background to be able to simplify the handling of data to such an extent that you don't realize what's going on.
This is a great example to see, like, if you look at the center image, you see that the head is kind of cropped out. So
Yes.
this is a very important kind of stage where I have realized so many mistakes that I've done with my augmentations, because this has all the augmentations applied to it just before being passed in basically for your processing.
Right.
So you'll realize things that you're doing wrong. It's not the input image, it's the input image plus the augmentations and all that.
Right, right. It's the input image going into your learner just before
Right.
you run all the losses and everything else. It's the final data stage. Like after this, you don't do anything to the data other than pass it into the learner.
All right. And just to point out again, like with Joseph's question, the way the get y is written here, that's how you would kind of tweak your get x to answer your question, where you can pass it a bunch of functions and it'll apply them in the chain like that. And I don't know, is there any other transform that you know of that you would not apply on the item transform, but apply for the batch transform?
That you would apply to batch and not apply to item, or vice versa?
I'm sorry. Yeah, you understood right. It said it the other way around. So the item transform, the only thing that I have only applied is like resize.
Yeah.
The tensor is only applied on the items.
Right, but that gets applied by default, right? Data block takes care of that.
Yeah.
Right.
But if you're going like on the low level, you always need to apply to that.
Right. Yeah. Okay.
Yeah, I haven't seen other than resize, but there may be others that we encounter.
Like there are double usages. Like for example, I think cropping and all, you can pass in a parameter which is on GPU or on CPU or something like that.
Right.
But again, like why not apply it on the GPU rather than apply it?
There are certain augmentations, like if you're using the augmentations library, most of the augmentations can't be done on the GPU, so you have to do them on the CPU. So you pass them in as item transforms. Those are like extra augmentations that are not in FastAI defaults. Yeah.
Yeah, actually, that is a good point. And it may be that the get items exist also for that reason. Besides resizing, is currently, at least in FastAI 2, he has provided the ability to run all these augmentation transforms on the GPU, so it's after batching. But there's nothing which prevents you from running them on the CPU after you've gotten the items. It's just that it's going to take you longer.
Right.
And so you could potentially apply it in the get in the item transforms as well. But then you would not be gaining the speed by, and each one would, obviously handle it at a different image and for the full image, blah, blah, blah. But you could do that and it'll just run on the CPU.
Right.
But I don't know why you would do it, because it is just, but there may be reasons to retain the flexibility to do that, which is you could augment on the CPU using item transforms. I guess that's the short form of what I'm saying. Okay, keep moving.
So just a quick question. Is there a way for us to look at all of the possible transforms applied to one or two?
Could you repeat the question, please?
Is it possible to see all of the different transforms applied to one single image, or a couple of examples? What are all the different things happening?
There's a ton of them. I believe in one of the earlier notebooks we went through, or the transforms, or maybe when we get into the details of the transform, there's an example. But keep in mind, actually, no, back a couple of lectures back, there is example where he takes, I think it was in the last transform class, but I'm not sure 100% about that. It's there in the, I definitely remember going through it. He even uses augmentation transform from not his own library, but the, I forget now what the.
Albumentations.
Sorry?
Albumentations?
Albumentations, yes, from that as well. So you could just build a very simple notebook and then go on applying.
I think Srinivas, Anand's question is like, can you see all the transforms that were applied currently on this data block?
Oh, I see.
And I think the answer is, if you look at org transforms, you should be able to see what is being applied at what percentages.
I was going there.
Right. So that gives us like a list.
Summaries.
I was asking more in terms of like the show batch. Be able to do that, like to see all of the transforms applied visually on one or two.
Yeah, and that's the example that I was talking about, exists in a notebook previously. I don't want to try it right now because we're going to.
Are you talking of the unique is equal to true?
So he's talking about, if I understand his question correctly, he's saying just like we show the batch, right, of just transformed images, he wants you could do that. He wants to see after items kind of images without the transformation. So image before the augmentations are applied. Let's say, let's stick with this image before any augmentation is applied, and then all of the different augmentations one by one, which shows here are all the augmentations that get applied to that particular image through the org transform, for example, or through albumentation. So that's is that right, Anant? That's what you're looking for, right? Yeah. And I think there is an example like that in a prior notebook. I would prefer not to do that now, given what we have to get to, but there is one where he also uses the albumentations transforms and illustrates what. But what Raquel was saying is something along the lines of, if you
just hover over.
Just a sec. I don't know whether that
just about the node. Yeah,
will that do it?
Yes, I think it should.
Or do I need to?
Can you click and then
this one before we go to the next? I can always do this.
In the meantime, I think to answer your question, Anant, isn't that kind of a random thing? So every time you get a new batch, those numbers will vary, like the probability of whether applying a transform or not applying a transform is going to change, right? So it's not going to be consistent if you want to see what transform was applied on an image. Every run it's going to change.
So yeah, I guess I was trying to look for an example where I can visually examine what my augmentation after.
Yeah, I think there is a notebook. I'll see whether I find it, and then if so, I'll post a link on Slack. But there is one where at least he doesn't, to Raquel's point, he doesn't go through every one of them, but he takes an albumentation transform, I recall, and kind of shows before after. But what Raquel is saying is, look, each of these is a P affine and P lighting and, blah, blah. Now, you could always create your own version of such a notebook where you make the P's 1 or 0, and then just build a notebook which shows you before and after every transform, making it a 0 or a 1, and you'll have the source to go back to. I've done stuff like that just so that I don't have to search when I'm in trouble, and debug is easier. But that's what you would need to do. You'd need to kind of provide it a single image, make this P's 0s or 1s, run them repeatedly and put them in a loop, and then just you'll see every image. But if you're trying to say I want to do it when I'm actually applying to see which got applied and which didn't. That is a little more hard, as Raquel was saying, because it's a probabilistic thing. Okay,
But,
moving on.
sorry,
Any
just
other
to add
questions?
one more thing. Just to add, with the show badge, there's another parameter which you can pass, like unique is equal to true. And that will show all the transforms, not all, it'll actually show you a bunch of transforms that were applied on one single image. So you can see how it's getting augmented like that.
Yeah, I think that will.
But that's what, that doesn't exhaustively show you all the transforms, and at the same time, it will not show you what is going to be applied at runtime, right? Because it will change. So you can get an idea, like if things are, like I said, getting cropped out or flipped around and it doesn't make sense, then yeah.
Yeah, this approximates pretty much what I was.
Cool.
So there's no decode method on this.
There is, right? That's why you're able to see the image as RGB. Otherwise, it would have gone down the tensor line and got normalized, and it'll be in the other range. Is that what you mean, Joseph, by decodes?
I guess what I was thinking about decode is that it keeps a record of everything it does, and then it, I guess, but you're right. I mean, the only thing you really need to get back is the original image. You don't really need a list of all the transforms and so on that were done in the augmentations.
Right, but yeah, let me see if there's a link. I think Zach did work on this, and he had a notebook which kind of showed what are some of the transforms applied. Let me see if I can find that.
Okay, good discussion. Now moving along, Pascal data set is something which is typically used to do object detection, but it's a great example of a multi-label problem, which means that we'll have multiple labels for, instead of a single label, you have a multi-label, so it's a multi-category class. Now, keep in mind that in this case, we will be getting the data from a data frame. So the Pascal source is here, and it's read as a CSV into a data frame. So that's what we are doing here. And if we look, I'm going to kind of talk through this while this loads. Sorry, I didn't preload this, so it'll take a little bit of time. But again, looking at the head of the data frame, what it tells you are multiple things. One, within the data frame is the name of the files, the labels which are in each of the files. So if, for example, this whatever 9.jpg will have both a horse and a person as the labels, and it also is valid. The is valid column tells you whether the image is in the validation set or not. So if the is valid column is true, that means that this particular file is actually part of the validation set. That's how we have to split. So you can see in this case that we'll be using a splitter which depends on the value of this column. If it's true, it'll put this image, the corresponding file name, in the validation set. If it's false, it'll put it in the training set. So that's just a look at the head. So now let's go through the questions. What do we have here? Images. The difference is it's multiple labels, not just a single label. So it's like the Planet data set for those who have worked with Planet, where you can have multiple cloudy and sunny and things like that. In this case, you would have multiple labels of what is in the image. Where is the data? Unlike in prior cases, it's actually in a data frame. How do we know is whether where it is? We know, or how to split is the better question. We split based on the column of our data frame. How do we get an image? By looking at the file name in the column. How do we know the label? We have to split this wherever a space exists within the labels column. So by looking at the label column and then splitting it. Do we want to apply a function to a given sample? Again, we need to resize. Do we want to apply to a function to a batch? Yes, we want data augmentation. So based on that, and again, I was just trying to find out what the details of the column splitter and column readers are. You can go read that yourself. I'm not going to go through those right now, but you can see that the data block has blocks, image block, that's simple enough, multi-category block as compared to a category block. So this says that a single image can have multiple labels. Splitter, we use the column splitter, which default column that to split on that's provided is valid. But if you get a different data frame where a different column is used to split it, you can provide that as input instead of the column splitter using its default value. Let's see, and then get X. Now here is a place where we use get X. What happens now is the fact that we use column reader and specify the column index, which is 0. Remember how we looked? The column index 0 is file name. That's why we say column reader 0. This is a prefix which says that this file name in the column 0 exists after this prefix. So it will be Pascal source / train / whatever, 05.jpg will be the actual name of getX. So that's what it will get as the image. Get_y is column reader 1, and the delimiter for the label. So it's smart enough to figure out that if I provide a space as a delimiter, sometimes you could have a semicolon or other things delimiting your labels in a data frame. So you'll need to change this in those instances. But here get_y is a column reader, use column 1 of the data frame I'm providing you, and a label delimiter, which is the space. Why label delimiter space? Because you want to find out all of the labels that exist in the labels column, and the different labels are separated by a space. So that's why you do that. Item transform, bad transforms. So you pass that in. And here he just explains what we have just done. And then you say data loaders, Pascal data loaders, pass in a data frame, and then you do a show batch on it to get you the labels. And again, as you can see, you will in a minute see all of the different. So you can see here for this image, for example, bottle, chair, dining table, person, sofa. So all of that has been tagged as labels in this image. These have only this one has 2, a chair and a person. Cow, I don't see the aeroplane in that one, but okay. TV monitor, person, TV monitor, blah, 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 dining table, person, potted plant. Oh, right there. Okay, cool. So now here is the example. Here's a different way of doing the same thing. Instead of using the column reader, you can specify a getX and a getY directly. And after using, well, it doesn't have to be after, but after providing the blocks, we still stick with the column splitter that is using the is valid equal true default thing. Here, we have changed the getX and getY. Just to provide you the reference, we use column reader in this instance of data block and set column reader 0 with a prefix, column reader 1, and I'm giving you the label delimiters. Here it says getX, and I'm giving you a lambda function and passing in X as a data frame. Pascal source train fx0, fx0, getY is lambda x x1 dot split, and then because you're not using the column readers, the column reader 1 label delim, you are having to do that in your lambda function, x1 dot split, and split on an empty space. And then these two are obviously the same as before. So the difference is in the getX and getY, and what you have done is somewhat what Beckil was hinting at before. You can just specify the specific functions that you want to do. And here you're just directly, instead of passing it again the prefix, you're directly giving it the entire source. So Pascal source train, and then basically the string x0 that says get the data frame 0th column and stick it after these, so you will get the name of the file. And hopefully that made sense. Any questions on that? And then again, you're just doing the same thing. It's just a different set of images. Now, a third way of doing it, this is not, at least not my preferred way. It's not very intuitive, but just so you're aware of all the different ways you can do that. you provide a getX. Again, the splitting is the same way, but a getX of lambda function again with the Pascal source train, and then O, because O is the data frame you're passing in, it says O dot file name. And then get Y lambda O and the labels column of O, and then you use the split function. So you're relying more on Pandas data frame capabilities when you do this kind of stuff. And
Just
again,
to point
you're
there
essentially
that F name and labels are the column names, right? The F name and the dot labels are basically the column names. So if you are doing this on your data set, you need to change those. Did that make sense?
labels.
If you go back to your data frame, the pd.read.csv.
Yeah, that's where I'm headed. Yeah.
So that F name and labels, that's where those two things come from.
Yeah.
It took me a while to find those. Yeah.
Yeah. Those are the column names of
exactly.
what
Others.
the data frame. So if your column names are different, you need to, his point is, if the column names are different, you need to change that guy and that guy. That's why I don't like this. This is an easy way to say it, but I think what he's trying to point out is here you're kind of using an index which is not intuitive, x0 and x1. Here, instead of an index, you're using labels, like file name and labels.
The other way to do that would be to do O bracket and quote.
Sorry?
The other way to do that would be to do something like
instead of O dot, you would say O file name in square brackets. That's what you're talking about, right? Yeah, I mean, that's
more intuitive.
Yeah, that's a Pandas.
Is it possible to use the column reader version, which is the first version, but instead of using the index, to use the name of the column?
Yes.
Sorry?
Yeah, we can. I've done that. So you can just put like a string there instead of like a.
That sounds more intuitive because it's hard for me to keep like that. No,
here,
one
instead
above.
Of 0, you're saying if you put labels as a string, will that work? Yes.
No,
above,
on the one above.
You're talking about
Yep, that one.
That one. Yeah, instead of yes, I think I've tried that too, and I believe it should work.
Yeah.
And that's where you can look at the column reader code, and I believe it'll get the name rather than just the index.
Perfect, thank you.
Column name, yeah. And the beauty of these things is if it doesn't, you can go modify this. And you could call that, and so it's kind of, since everything is accessible, and you can make it your own version as well. Okay, so moving on, the most efficient way, and again here he talks about efficiency of using the pandas. All of the above may not be that efficient, is to convert it into the NumPy arrays and then use the from columns method. So that's what he's doing here. Is he's converting it, and then the reason he explains is because of the pandas details of going through it row by row is much worse. And here he also throws in usage of index splitter, because this is an example of what Raquel was talking about earlier of how to create multiple validation sets. Here we are just again doing only one validation set and a training set, but the point is that you can provide an index splitter with indexes. So let's see what we're doing. So we're saying define the Pascal items to return. The source is x.fname, which is the name, and the labels, but the labels in the pandas data frame are a string, so you split them. We saw the need to do that, like it'll split the bus and the person, for example. And then the valid IDX is where he's creating a DF, and then DF is valid, taking the index and taking the values of the index, which means you have grabbed all the valid indices from your data frame. That's what this does. And so you can pass in the data block, and instead of doing what we did before, you can say data block from columns. This data is that you pass in is the same, the type of blocks. You get the items, use the splitter, and here you use an index splitter. Remember that when you use a index, ultimately the splitter, and when you use an index splitter, what you pass into it is the valid indices or the valid indices. And the valid indices are what you have generated by using that line. And you pass that in, and therefore it knows that those indices are to be used as validation indices and the others as training. And the rest remains the same. So you just execute that and we get the same result. So these are just
nice to point out the fact that, you know, he didn't use a get y in this case. So which shows that in general, get x and get y are no ops. So you can use your get items for literally everything. Like he didn't use a get y in this data block. He did everything in the Pascal items function. Yeah, he passed in. He got the tuple from there. So yeah, highly flexible.
Yeah, he got the tuple from, remember that he just replaced underscore Pascal items as the get, passed in underscore Pascal items as the get items function for this data block. And that's a good point he's making of, if you see, notice there's no get x, get y. So the default get x, get y's are no ops. Okay, now
one question there. So is there like, I forgot what, is there like a rule of thumb when you would use like a dot from columns method? What scenario?
I think he seems to indicate that it's more of that it's a performance optimization.
So it's still a data frame scenario. I would use a dot from columns and just smartly write my get items.
Yeah, the other thing he talks about is that you know, if you use this method, you lose the data frame after extracting the relevant columns. We can't use column splitter anymore.
Oh, okay.
So that's why he goes to an index splitter if he's using the Pascal items this way.
Okay.
So that's something he talks about here.
Cool. Okay.
Right. So did we execute that? Okay. So now image localization, which is essentially segmentation. That is, you know, identifying the individual pixels as belonging to different classes. You do that using the Cambit tiny data set. Again, same questions, images, mass as part of your labels for your categories. Where's the data? How do we know? Again, we take a random split, label. Here, the labeling is a little more complex. The labeling of the mask is obtained through reading this text file, which has strings, which tells you the codes for the various masks that exist on the image. And do we want? Yes, we want data augmentation. So again, Cambit is just a data block. The block type varies, especially for the mask, which is stuck onto the actual image, or basically classes. It identifies the various classes into which the mask fall. Get items is get image files, splitter random. Here on get y, if you look at the details of the segmentation, you'll find that the value is provided in this o.stem, which is the basic name of the file, the stem, and then the o.suffix underscore capital P, and the o.suffix is how you grab the labels or the mass, and then you apply the awk transforms. So you need to understand a little bit of how the data is set up in case of most segmentation problems. And in the case of Cambit, this is the way that you obtain the mask labels, and you need to supply this file for mask block. So you run that to set up your data block. And so he talks about why the code string is needed, because it indicates the correspondence between pixel values of the mask and the object. And then the rest is all very familiar, and you create a data block. So it kind of, you know, the beauty of this mid-level API is the fact that with the same API, you've seen now multi-labels, single labels, getting it from data frame, getting it from folders, getting it from grandparent, parent label splitting. You've seen it used in segmentation, and now we'll see it used in Kinect head post data set, where we're trying to identify the midpoint of the head of individuals. So in the interest of time, I'm going to keep going. And so here again, the nature of the block that you provide as the label is different. Just to provide you context, the point block is the red dot that you see in the center of the face of the person. And you can see that here, you can see that here, and so on. So the idea is you want the problem is to learn to locate the center point of a person's face in the image. And that's the training you go through to solve this problem. And so in this data set, you, just a second, I'll get to the question, and then you provide a point block, and the rest of it you can kind of figure out, except that get y is lambda o. Here you just provide this particular function, which is, I think, file name to center, and then you get the name of the file, and then forget the flip zero what it does, but it's to label the image, or sorry, to label the, to find the dot in the image, and then you provide awk transform. Yes, there was a question.
Yeah, so is it the point block that lets the batch transforms know that the transforms are also y? For because when you augment.
Sorry, I couldn't hear you, and kind of a lot of echo. Or if somebody else heard, could they repeat the question, please?
I think his question is how X and Y in the scenario, Y also needs all the transforms to be applied to it, right? Because as your image moves, your point is going to move. So I think his question is, how does the point block, I mean, how does it know that you need to move the Y also in this case?
The Y being the
yes.
label.
I think the answer to that is like the way the point block is set up. It's like with the type dispatch, you know that, okay,
Yeah,
if it's a type of point block, then you need to move along. And it's the same thing with the previous one also, right? With the segmentation example, also it's the same thing.
Yeah, even for the multi-category block, it's the same thing, right? Because you'll need to know that it's a multiple category. So I'm okay to assign multiple labels to the same image.
A multiple category, you're not, augmentation is applied only on the X, right? Only the image is going to get rotated.
Okay, I see. The question being that here, the augmentation also have to apply to the Y.
Right.
Yeah, but that is, as you said, it depends on the data type, which is the reason that you provide the data type here. So it would, so the short answer is it would be part of the point block code that it needs to, when you use a point block, then whenever augmentations are applied on X, then on an image, it would also need to be applied on a point block. So moving, well, let's execute that code. And then, so now here it just is, after applying that, it just shows.
Just one more question. Is the mention of not using Lambda there in this notebook? Because I think it's there somewhere, right? Like if you use Lambdas like this in getX and getY, they could create issues while pickling.
Yes.
So we always suggest to fall back to using
actual functions.
Yeah.
Named functions, right?
Yep.
Yeah. So yeah, and you know, he's just in the interest of time or simplicity is put it, but it's very easy to, like you saw in label function or something else, take this, stick it in a function, and then pass that function to get y. And that's an important point Rekel brings up, because you'll see it, well, not in this notebook. I think we'll run out of time, so we'll do it next week. About when we start with the transforms notebook, you'll see that he tries to pickle transforms and it works, but it won't work if you use Lambda functions within a transform or within even the data block. So yeah, that's a good reminder to not use Lambda functions within a data block, but to just define a function outside and pass it in. Okay, so we executed that. Now we go to bounding box. Again, for simplicity, skip over this to, you can look at the get annotations code. For those who are familiar with the COCO dataset, it will just provide the set of bounding boxes with labels on them. And so we get the data. In this case, we need to get the annotations to the data, which are in JSON files, and they come in a way that you can split them into images and then the label bounding box, or actually there's the bounding box label. And the image to bounding box just creates a dictionary of images and the corresponding labels of the bounding boxes. So this will be a dictionary of images with the values being the labels of the bounding boxes. And then we go through the questions. Input is image. The bounding boxes, in this case, we get two values. We haven't seen that before, but it's a bounding box block. And then it's also a bounding box label block. So it's not just the bounding box, which has the coordinates. So you need to know where to draw the bounding box with the coordinates. But the bounding box also has a label that you want to know what it is. So it's both of them. And then get image files, randomly split. Remember Reckl's warning, but keep it simple. Lambda O image to bounding box, use the name and then the 0th value of the image to bounding box name, and then the 1, which is just the coordinates and the label. Item transforms, batch transforms here, and this is a good example of what we were discussing earlier. You provide n input as 1 because what you want to tell it is, hey, I'm giving you multiple types of boxes and multiple types of blocks. My input, or what I want you, the data block, to treat as input is just my first value, and then everything else is not input. So it just treats that first value as the X or the input. And you define it that way. And here you provide 3 types because we have 2 targets, the bounding boxes and the labels. And this is the reason we provide an input is 1, because we want to say, where do the inputs stop? Input stops with 1 and the targets begin. So this also points out that I made a mistake. It's not Y, it's multiple, it's X, because if you had multiple inputs, for example, in Siamese, you would have multiple inputs. You have 2 images and then you want the label to be true or false. It's kind of the opposite of what we are seeing here. Here we are seeing 1 image. So you say n input is 1 and multiple labels, or multiple Y values, I should say, bounding box and the label. So you run, after you built the data block, you run that and you show, and you can see that, let's see, where is multiple, simple one here. Couch, multiple couches, and a book. Well, actually multiple books too. And then here, it did multiple bounding boxes for chairs, 4 of them, and then a vase, I believe. Okay, and then just to illustrate, so far we have always fiddled around with images. Hopefully we'll be done in another 3 or 4 minutes. Here, using the data block concept for text, and we can also see it used in Tabular. So here you build a path, IMDb sample. So in this case, we're actually using it. Let's see. This is where we get the data from. And let's see, is he using it for text classification? Actually, you can use it for both language modeling as well as text. And here we are using it initially for the language model. And so now again, we ask ourselves the same question. And what are the inputs and targets? For a language model, keep in mind that there is no target. The target is just the input shifted one place to the right, because we want to do in a language model is predict the next word. And so there isn't really a label, if you will. It's just the input shifted right. And since the target is derived from inputs, where is the data? It's in a data frame. How do we blah, blah, blah? Again, we use an is valid column. And how do we get the input in the text column? So you build a language model using a data block, and you say blocks. And in this case, slightly different way of doing it, text block from the data frame. You provide where, or the string which indicates the where the data is, or the name of the data frame. You say is LM is true if you're building a language model. And for the X, you say column reader, because ultimately you're using a data frame and you're using the text. The name of the data frame is text, and you use the column reader. And for a splitter, you use column splitter, and I would imagine you use the default values of column splitter. Interest of time, I'm not going up to see what the default values are. Run that data block definition, and then you are ready to load in the data loaders. Unlike previously, in this case, you see that to the data loaders, you pass in the data frame and you pass in the, because it's a text value, you need not just the batch size, but you also need the sequence length of 72, which is what you chop it by. You run that and you can get the text, and you see this is the input text, and you can see that the labels are just this text shifted by 1. You see the early 1900s, and then you see early 1900, da, da, da. And then you can do the same thing for text classification. And because you're classifying now, you say that your label is a category block, because it's a true or a false category. And then you get the X, which is the text. And in this case, you get Y from the column reader, which is a label, which is the true or false value. And then you use the column splitter. And the important thing he points out is the fact, and I'm going to rush through this so we're not late for the hands-on machine learning, but the important thing he points out is you need to use the same vocab in the two cases, otherwise you can get in trouble. And also the sequence length argument, the setup is default 72. You could change it to 80 and stuff if you wanted to in your text classifier learner. So the sequence length in the text block and the learner would have to be the same. I haven't quite figured out, and I haven't spent too much time looking into why after the first one it becomes all padding, but you're welcome to look into that and post the answer to that question. Interest of time, I'm moving to the last example, tabular data. So just use tabular data, load tabular data. So adult sample, for those if you're not familiar with the data set, it's basically a bunch of values, and your goal is to predict in the table whether somebody makes greater than or less than 50K in their salary. So that's the goal of the data set. And here are all the features that go into it. And in a tabular problem, you need to specify what are the category names and what are the names of the continuous columns and the category columns. You do that. And you, as we have seen in the hands-on machine learning, as well as in when we went through, I think Joseph took us to the tabular processing in FastAI version 4, we applied categorify, we filled in the missing values, we normalized the values for the continuous variables. So you apply these processes. In fact, I forget what they're called in hands-on machine learning, but they have the name. It's similar to what you do there of just applying. But in this case, it's smart enough to figure out, or FastAI is smart enough to figure out that categorify only applies to category column, fill missing is applied, I think, to the continuous columns, if I'm not mistaken, and the normalize is applied to continuous columns as well. And he talks about what each of these does. Here, we are just going to do a random split based on the length of the data frame. And from the length of the data frame, we collect range of, which is indices, so that you can use a random split of indices to generate your test and your validation and training set, and create a tabular object by passing in the data frame, the procs, which are things you run on the various columns, the names of your categorical columns, the names of your continuous columns, the Y name, which is the label that you want to predict, the splits, which are your random split based on indices, and the Y block is a category block. So you can see that in case of tabular pandas and tabular object, the way you pass in the data block is somewhat different, and we'll get into that. There's an entire lecture devoted to just the infrastructure that supports tabular pandas. And as you see, he specifies why you say Y block is category block. And you don't have to do that, he says, because it's usually inferred from the data. And then you do the same thing. Data loaders, you turn the object and call the data loaders, and then you show batch, and it'll show you a batch of the data. Questions?
No, you've done a terrific job, Srinivas. Thank you.
Okay, thanks. And we'll begin to go through the transform testing and coding of the transform using some Python capabilities of meta classes and stuff in the next lecture. In the next part of the lecture, we haven't even gotten through about 13 minutes of his 1 hour lecture yet. Okay, great.
Is that video 6, Srinivas?
No, video 5.
Okay.
He just waves saying, you can go through this notebook in detail. I've just put all the data there. And then the next part, which will probably take 45 minutes, he just takes 10 minutes to go through he actually doesn't go through the testing, but it'll be very useful for us to go through how he tests the transforms, which makes us better understand what we did in the last lecture. And then we'll get into the actual code that supports the transform, for which he uses meta classes and the details of type dispatch and things like that. So we'll get to learn a lot more about transforms, the testing of transforms, and the code of the transforms in the next lecture, which is again lecture 5 itself, starting at around 5 minutes into the rest of the lecture. Okay, if no further questions, thanks a lot for joining, and see you all next week when we get into transform details.
Thank you, Srinivas.